Section 4.4, Solving more linear equations in one variable. So let's look at some more examples of equations that are a little bit more complicated than what we were solving in the last section. So we're going to start out solving each of the following, and with part A we're looking at 5x minus 1 equals 9. So our goal in solving equations is trying to get x by itself. So if you think about what's happened to this x right here, it's been multiplied by 5 and then we subtracted 1. So if you're trying to get this x by itself, you're going to need to get rid of that 5 and the 1 to get the x alone. And to do that, you want to do things in the opposite order that they happen to x. So if this x would be multiplied by 5 and then we'd subtract 1, then to undo that we'll want to add 1 and divide by 5. So let me show you those steps. We have the minus 1 right here, so we would add 1 to the left side, with the goal there being to cancel that 1 out. But if you're going to add 1 to the left, then to keep things balanced, you have to add 1 to the right also. And then you could say these 1's cancel. And that takes us to where we have 5x equals 10. And then we want to get x by itself, and so that means getting rid of this 5. The 5 is connected to the x by multiplication, so the opposite would be to divide by 5. If we divide the left side of our equation by 5, we need to divide the right side also. And then 5 over 5 is 1, so those cancel out, and we're just left with 1 times x, or just x. And then simplifying on the other side, 10 over 5 is 2. So x equals 2 is our solution. Alright, let's look at another one, just following that same pattern. I'm trying to get this x by itself. First thing we're going to do is try and get rid of this 8. So we subtract 8 from both sides. These 8's cancel out. On the other side, well, let's see, sticking with the left, after the 8's cancel, we still have a negative x. And then on the right hand side, we have negative 12. And just a reminder from earlier in this chapter, we said that if you have a negative in front of an x, that's the same as if you had negative 1 times that x. So I'm going to think of that as negative 1 times. So to get x by itself, I'll do the opposite of multiplying by negative 1. I'll divide by negative 1. Do that on both sides of the equation. The negatives would cancel out, and I get x equals, and then a negative over a negative is positive, and with a 1 denominator we can get rid of that and just write x equals 12. Alright, so now let's look at part C, where we have w as our variable, and the w is located in 2 different spots. When that happens, you want to get those letters together on one side. So what I'm going to do is try and move this 4w over to the left, or another way of thinking of it is I just want to get rid of it on the right. So to get rid of that 4w, I would subtract 4w, because whenever the connection is addition or subtraction, you always want to add the opposite. That'll cancel these out. And then for balance, I'll need to subtract that 4w from the left also. That gets me to, let's see, combining like terms, negative 10w. Then we have the minus 3, and that's equal to 17. And now this looks a lot actually like part A, so we just want to do some more steps. We're trying to get this w by itself, so the first thing would be to add 3 to both sides. These will cancel out. So we get negative 10w is equal to 20. And then the negative 10 is connected to w by multiplication, so we'll do the opposite, which is division. The 2 negative 10's cancel out. We have the w all by itself. And let's see, what is w? 20 over negative 10. So 10 goes into 20 twice, and a positive over a negative is a positive. So we get negative 2. Alright, moving on to part D, complicating things a little bit more. Now we have the parentheses there, so when that happens, our first step would be to clear the parentheses. So we're going to use the distributive property to get started on that. So I'm going to distribute a negative 3 here, and just a negative sign over here to clear those parentheses. So let's see where that would take us. The 1 would just stay as is, and then negative 3 times 5b would be negative 15b. Make sure you do remember it's a negative 3 you're distributing, not just a 3. And then negative 3 times negative 2 would be positive 6. And we have our equal sign. Our 4 will carry over. And then remember, if you're just distributing a negative, that just changes the signs of everything inside the parentheses. After you've cleared the parentheses, you should look to combine like terms. So on the left hand side we have the 1 and the 6, so I'll combine those, and on the right we have the 4 and the negative 3 as our like terms. So simplifying that, let's see, I'll copy the negative 15b first. I like to have the variables first, constant second, kind of that mx plus b sort of look. and then 1 plus 6 would be plus 7, and equals on the other side the negative 7b, and then 4 minus 3 would be plus 1. And if you look at what's happened after we cleared the parentheses and combined our like terms, we're actually in a spot that looks an awful lot like part C. So I'm going to try and move this 7b over here and move the 7 over there. And a lot of times I'll do that in the same step. So to move this negative 7b over, I would add 7b to both sides. And you could just do that step if you want, but a lot of times at the same time as I'm moving the variables to the left, I'll move the constants to the right. So I'll subtract 7 from both sides at the same time. So those negative 7's cancel, these negative and positive 7b's cancel, and let's see what's left over. Negative 15 plus 7 would be negative 8b, and then on the other side 1 minus 7 would be negative 6. And now we want to get this b by itself as our last step, and that negative 8 is connected by multiplication, so we'll do the opposite, which is division. Those cancel out, and then we just need to simplify here. Negative over negative would be positive, and then there's a 2 we can cancel. That 2 would go into the 6 3 times and into the 8 4 times, and again the negatives would cancel each other out as well. So it looks like our answer would be that b is equal to 3/4. Alright, let's go ahead and look at one more. This one has fractions in it, and so that's going to be a little bit more of a challenge. One of our options would be to just go ahead and subtract 2/3 from both sides right away, and that'd be very similar to what we were doing on problems like B and C. But if you move that 2/3 over and try to combine that with the 2, you'll need a common denominator to make that work, and you'll be working with fractions through the whole problem. So another option is to try and clear the fractions. So you look at the fractions you have and you think about what's the least common denominator. In this case that would be 6, and you're going to multiply the left hand side of the equation by 6, and you're going to multiply the right hand side of the equation by 6, whatever the LCD is. And then on the left side you'll do the distributive property, and so we get 6 times 5x over 6 plus 6 times 2/3, and on the right side 2 times 6. And the reason we're doing that is if you multiply by the LCD, then every term will have that LCD as a multiplier, and the denominator always goes into the LCD, which means you would always be able to reduce your fractions away by taking that step. So here the 6's cancel, here that 3 goes into the 6 twice. And after you're done with that step, the fractions are gone. You have 5x, let's see, plus 2 times 2, so plus 4, equals 2 times 6, which is 12. So we still have an equation to solve, but by multiplying by 6, it's an equation now without fractions. So subtract 4 from both sides, and that takes us to 5x equals 8. Divide both sides by 5, and we get x equals 8/5. So if the answer to the problem is a fraction, there's no way to avoid that. But you don't have to work with fractions the whole way through. You can multiply by the least common denominator early on, that'll clear your fractions, and then you can just continue on with the rest of the steps. Alright, so we've looked at 5 different examples here, so I want to go ahead and summarize the steps that you would use to solve equations like this and kind of the order that you would think through those. So the first thing that you want to do is remove any parentheses that might be in the problem. And I'm saying parentheses, but if it happens to be brackets, braces, any grouping symbols, you would want to remove those. And then if there's fractions, you want to remove the fractions. And the process there is to multiply both sides by the LCD of all the fractions that are in your equations. And the other way you can think of that is if you look at what happened on this, yes, I multiplied both sides by 6, but because the distributive property, really what that means is I multiplied all 3 of the terms by 6. This one, and that one. And that's true whether there was a fraction or not. So a lot of times the official step is multiply both sides by the LCD, but I'll think of it as multiply every term by the LCD, and that's equivalent. And then once you've done that, you want to combine any like terms that you have. And then you want to try and get the variables on one side. So you're going to use addition, subtraction for that process. So use addition or subtraction to get the variable terms on one side and the constant terms on the other. So that would be like up here where I added 7b to move the b's to the left and subtracted 7 to move the constants to the right. And then multiply or divide to isolate the variable. So that's pretty much always going to be a division step. So if you look at our last step, we had 5x equals 8 here, so we divided by 5 to get x by itself. The only way that would ever be a multiplication is if you had a denominator, and according to these steps you would have gotten rid of any fractions in step 2. So typically books will say multiply or divide, but if you're clearing fractions like you're supposed to, it'll always end up being a division step. And then finally you can check your answer, and that's usually optional. And you can kind of see that that's optional in a way because I didn't do that on any of the 5 that I just went through. Alright, so those are the steps that we're going to use to solve equations from here on out. Alright, continuing on in section 4.4, let me just show you a couple more examples now that we've seen all the different steps that are applied to equation solving. So on this one we have parentheses, so according to our list that we just went through, first step would be to clear those parentheses off. There's nothing really for me to do on the left side to simplify, so I'm just going to copy that. And then using the distributive property here, 3 times 2x is 6x, and 3 times negative 1 is minus 3. And the 5 was not in parentheses, so the distributive property doesn't apply to that part. These two are like terms, so I'll combine those. So negative 3 plus 5 is plus 2. And now I have a constant on the right and variables on both sides. So if I subtract 6x from both sides, that'll cancel off these 6x's and having the effect of moving my x's to the left. And then at that point I have 4x minus 6x, which is negative 2x. And on the right I have positive 2. And then just a single step left, which is divide both sides by negative 2. And cancel these negative 2's off. And x is equal to 2 over 2, which is negative 1. And then let me show you one more, and this one has the fractions in it. It has 4 terms. So 1, 2, 3, 4 terms. I'm going to multiply every one of those by the LCD. Looks like the LCD would be 8. Every one of these numbers will go into 8. So I can multiply both sides by 8. And I would always put that in parentheses if there's more than one term. But then the distributive property applies. So what that's going to look like when I carry it out is multiplying every term by 8. So I get 8 times 5 fourths plus 8 times 9 halves x, and that's going to be equal to 8 times 3 eighths x and minus 8 times 1 fourth. So every single term gets multiplied by that 8, which has the effect initially of making this look a lot messier. But right away, because that's the LCD, every one of these denominators should cancel. This 4 goes into the 8 twice. This 2 goes into the 8 4 times. These 8's cancel. This 4 goes into that 8 twice. And all of my denominators are gone. So now as I continue on simplifying this, I'm going to have an equation with no fractions. Just multiply the leftovers. 2 times 5 is 10, plus 4 times 9 is 36, and we have the x there, so 36x. On the right hand side, the 8's just canceled, so the 3 and the x are left over. And then the 4 into the 8 twice, so negative 2 times 1, or negative 2. And so yes, temporarily this got a little messier looking, but then as soon as we crossed off all those denominators, a much simpler looking equation than that first one we had with fractions in it. So that's a really key step to be able to do, to take those fractions and clear them all away by just multiplying by the LCD. Just such an easier equation to solve after you're done with that. So then I would subtract 3x from both sides to move the x's to the left. Subtract 10 from both sides. That'll move the constants over here to the right. Finishing it off, we have 36 minus 3 is 33x. And negative 2 minus 10 is negative 12. The 33 is connected to the x by multiplication, so I get rid of it through division. Divide those out, and now I just need to simplify, and both those numbers are divisible by 3. 3 goes into 33 11 times and into 12 4 times, and I've got that negative over a positive, so it looks like x will be equal to negative 4 over 11. And by the way, just thinking back to those steps on the previous page, it said that checking was optional, and at this point I would think, well, that's lucky for us, because otherwise we have to take this negative 4/11 and plug it in right there and simplify both sides and see if they're equal. So if you want to do that, you can, but checking is an optional step for us. There are some places in algebra where that's not true, where you have to check. If we run into those, I'll definitely alert you to the idea that the checking becomes mandatory. But for now, It's just something you can do if you want to be on the safe side and see if your answer worked out. Alright, continuing on in section 4.4, let's go ahead and look at an example of equation solving. So Martha Stewart went to prison for selling nearly 4,000 shares of M-Clone Systems stock because she had inside information that the company was about to announce bad news that would result in the stock's value plummeting. Surprisingly, the value of a share of Martha Stewart Living Omnimedia stock increased by about $3.36 per month after she was sentenced. The value of a share of her stock was at $8.16 just before she was sentenced. Let V be the value of a share of the stock at T months since Stewart was sentenced. And they want us to find an equation of a model that describes the situation. So at this point, really the only type of model we know how to do is linear. So I'm definitely hoping it's going to be a linear type model. And I want to think about doing things in a y equals mx plus b sort of format then. Except for those are not our variables. V is going to be one of our variables, the value of the stock. The other one will be at T months since she was sentenced. I would have an initial hunch that this would be the input and that would be the output. But one way you can try and double check that is to try and find the slope. So I'm going to look for the word per. And let me switch colors. I see that right here, $3.36 per month. Remember, the slope should be about change, and it's talking here about an increase. So our slope is going to be positive. Slope also has both types of units in it, so dollars per month. And then remember that whatever is in the denominator of that is your input, and the units in the numerator are the output. So it looks like the dollars is the output, so that would in fact be value. And months would be the input, so that would be T. So we're looking for V equals M times T plus B. And we just found the M. Right here we found the per, all that sort of stuff, and we were convinced that was our slope. So M is equal to 3.36. So now we just need to find B. B is usually some initial value. B would be 0, comma B. So we want to think about 0 months since she was sentenced. Well, 0 months since she was sentenced as an input would mean at the moment she was sentenced. And it says the value of her stock was $8.16 just before she was sentenced. So I'm going to take that to mean also at the time she was sentenced. So this number right here should be our B. So it looks like M is 3.36 and B is 8.16. So we can take all of that, plug that into the equation, and we get the value of her stock should be the slope, 3.36, times the input variable T plus the initial value of that stock, which was $8.16. So there's our equation. The value of the stock is 3.36 times T plus 8.16. Alright, so now let's try and use that equation to estimate the value of a share of the stock 3 months after the sentencing, which is about the time she reported to prison. So let's see, 3 months, that is not a value, that is a time, so that's our value of T, and we're looking for the value. So I'm going to plug this into the T and get that the value is 3.36 times 3 plus 8.16, and at that point I'll just go to the calculator to finish that off. Alright, so let's go ahead and bring the calculator in here. And let's see, we have 3.36 times 3 plus that initial $8.16 gives 18.24. So the numerical answer is 18.24, but we always want to think about units on any application. This V is for value of the stock, so this would be $18.24. And then estimate when the value of a share of the stock reached $28.32. Notice values are the dollar amounts, so this is a V right here that they're giving us. So I'm going to want to use the equation again, but this is going to get plugged in for V, and then I'll be solving for T. So instead of V, I'm going to write 28.32, and then I'm just going to copy the rest of the equation, 3.36 times T plus 8.16. And now we've got an equation that we would want to try and solve, much like the ones on the previous pages, except for this one happens to be messier with decimals. I don't worry about decimals being messier really, I'm just going to use the calculator to help me with any calculations. I want this t by itself, and it's the only t in the problem, and it's on the right hand side, so I'm just going to leave it there. So I'm going to try and move this constant to the other side, so subtract 816 from both sides. And then we could use the calculator on this, or this one actually looks fairly easy to do. That's 20.16, I think, and that would be equal to 3.36t. And then we want that t by itself, so we divide both sides by 3.36. That would cancel that out on the right. Need to divide it on the left as well for balance. And then I just want to see what that is. So I'm just going to go to the calculator over here off to the side on that. So 20.16 divided by 3.36, and that turns out to be exactly 6. So then we want to think about units. 6 pounds, 6 feet, what is it? So let's see, we were solving for t. T was the number of months since she had been sentenced, so 6 months after she was sentenced. Just a little bit of commentary on this problem. It's kind of interesting thing that Martha Stewart was the CEO of this company, and she gets sent to prison, and then what happens to the stock? According to the equation and the story that they tell us up here, every month after she was, like for each additional month she was in prison, the stock price went up $3.36 each month. So that seems pretty strange when the CEO goes to jail and the value of the company goes up. So if that was seeming strange to you, I do remember this event, and essentially what happened is when she was kind of arrested, her stock value went way down, and when she was sentenced, she didn't get as long or as harsh a sentence as people thought she might. So basically it was this kind of relief of the stockholders that she wasn't going to be in prison very long, and so that the stock started to rebound shortly after they heard what was kind of good news, that her prison sentence was going to be short. Good news for the company anyways. Alright.